Hi everyone, welcome to my talk on privacy design strategies for home energy management systems. My name is Kopo Ramokapane. I'll be presenting this work on behalf of my colleagues Caroline, Awais, and Ruzanna. In the past few years, there's been a huge interest in energy management. Therefore, there's been a high number of smart meters, smart appliances, and even mobile apps aimed at helping consumers manage their household energy. One technology, though, that is gaining a lot of traction is smart home energy management systems. These are complex systems used to manage and monitor electricity. Unlike smart meters, though, they do a bit more. They can automate activities. For example, they can switch between energy sources or automate when an appliance should be on or off. As a result, they tend to generate and create large amounts of data. And unlike traditional consumption data, this data can be more detailed. For example, they can track individual appliances. In other words, this data creates a lot of opportunities. And for users, for example, it gives them opportunity to see consumption at real time or view this on different devices. And for new market, it creates opportunities for people to create new services for people. Despite these opportunities, though, data at this level poses various challenges. It can be used to surveil consumers or allow utility providers to have some sort of control over how consumers use their electricity. And these concerns they can lead to less adoption of these systems, and which may eventually have impact on the main grid. Since data is important for provision of electricity or even to help manage demand and supply of energy, my colleagues and I wanted to find out how utility providers can collect and process this data without violating users' privacy or excluding others. We think this is timely because many countries are adopting energy management systems and they are pushing for more data that could help them manage the demand and supply curve. We deployed two methods: first interviews, then privacy design framework. To understand how users perceive energy data or the conditions that may encourage them to share this data, we recruited two groups of participants. The first group consisted of participants from Replicate project, while the second group included consumers who were not attached to any energy related project. Replicate is an European project aimed at exploring how energy demand can be managed better. It started in three cities: San Sebastian in Spain, Florence in Italy, and Bristol in the UK. Participants from Replicate project had access to various smart appliances and devices, including energy management systems. And these were people who were mostly interested in energy related issues. While non energy participants were people who had no access to energy management systems. The second part of our method involved deriving privacy strategies for home energy management system. We use this privacy design framework because it builds on the notion of privacy by design, that is, incorporating privacy right at the development stage of the project rather than later. This framework forms the first part of the development phase. It aims to model a way in which designers can formulate system requirements that address privacy issues outlined in laws or policies. What did we find? Our analysis revealed that data collection and sharing attitudes were highly influenced by five key factors: incentives, participants' desire to share energy or save the planet, trust, accountability, and protection assurances. I will only present the first three. Full findings can be found in the paper. In terms of incentives, many participants revealed that they would be happy to share data to get correct bills. They also suggested that data collected to ensure correct billing should be mandatory, while the rest can be optional. Other participants' interests were mainly focusing on the benefit of everyone. For example, allowing data to be collected to help balance the load on the main grid. Other participants wanted mandatory data to be used to promote green energy, while optional data could be used to develop new technologies. We also found that other attitudes were mostly influenced by who was collecting the data. They reported that mandatory data should only be collected by energy companies, reasoning that this data should remain with companies that are relevant to energy sector than other companies who may just have other business interests. Regarding users' concerns, we classify this into three main groups: security, data misuse, power relations. Regarding security, we found that participants were worried that these systems could be hacked, their data stolen, leaving them at risk. Others were concerned mainly about how their energy data can be misused. They said companies could make profit from their data because they themselves do not know the opportunities that come with energy data. Others complained that they could also be penalized by these companies because of how they use energy. Lastly, most participants were concerned of losing control or the provider having much control over them because of how they use energy. We used the result from our analysis and then derive privacy design for home energy management system. The full list of this can be found in the paper. To conclude this presentation, I'll share some takeaways. We found few differences between participants' views. In most cases, participants held similar attitude towards data collection and sharing. They all wanted to pay the correct amount, save the environment, and wanted security over their data. However, we noticed that participants from replica project were more likely to be influenced by what they would gain as a result of sharing, or whether the data collector promoted green energy. We think this is because they are already benefiting from participating in an energy-related project, and also they have a better understanding of what energy data entails. We think environmental reasons for sharing data may outweigh privacy reasons in most cases, therefore make people share more data. Participants who were not part of Replicate, they had similar views to those that have been reported in other papers. However, we noticed that they were less likely to share data with local authorities than their counterparts. They also seemed less worried about the utility provider having control over them. In terms of energy data and other data, we learned that users do not really understand the difference between energy data and other data, especially data from other smart devices. They think it's harmless. For example, one participant said, "I don't really care if people knew my washing machine was on or off." They believe that everyone does their laundry, therefore, they have nothing to worry about. Our results also suggest that ownership of energy data is important to users. They feel like it's an asset and they should benefit from it, unlike other services where data can be exchanged for a free service. In the case of energy data, they are paying, so they should also benefit from sharing the data. Why should energy data be protected? Well, energy management systems and collection of energy data may become standard in most countries. Therefore, protection of this data may be of interest. There are also issues of discrimination. Energy data should be protected to minimize the exclusion of certain people and communities. Our results also show that people are more likely to share data for sustainable reasons and neglect the risks around data sharing. Therefore, this data needs to be protected by default. Thank you.